Hi, folks. Happy Monday. How's everyone doing?
Good.
All right, so we're going to go ahead and get started. I've got some announcements for today that I just want to make sure we've all seen. So I'm going to go ahead and share my screen so that we can take a look at those announcements on Canvas. Okay. So we are in week 5, which means you folks are at the halfway point. You've made it halfway through, you've got 4 weeks left, and then hopefully you will find yourselves prepared for whatever class you want to take next. So a few announcements this week. Okay, so the first thing is that you have exam 3 tomorrow. A few folks had requested that we begin the exam earlier to fit more with their schedules. So exam 3 is going to open tomorrow at 9:30 in the morning. Okay, it will be open at 9:30 and it will close at 9:35 on Wednesday, July 8th. Okay. We will not meet for class tomorrow, so you don't need to sign in. You only need to access Canvas so that you can get your exam and then work on it from there. I want to clarify a few things. Your uploaded exam must include a cheat sheet, a statement of integrity, which you have to copy out by hand, and then you have to sign it, as well as your exam. If you do not include a cheat sheet or a statement of integrity, you will lose points. Okay, your exam must be uploaded to Canvas by 9:35 on Wednesday. I will not accept late exams, so please make sure that you get that in on time. All right, you can also click here for a point outline on exam 3, so you can see how many points each topic is worth and use that to guide your studying as well as your cheat sheet. All right, the week 5 schedule. So today we're going to finish 7.4 and cover 7.5. We will not meet tomorrow. Again, that is time for you to work on your exam. On Wednesday and Thursday, we will reconvene and we'll be covering sections 8.1 to 8.4 in your textbook. And I did want to bring this up. It seems that most folks are not attending lecture, which is fine by me, but I may adjust the schedule. So instead of having lecture, I may just post all the lecture videos in advance so you can work through them at your own pace, and then have office hours a few days instead of actual lecture. Okay, so based off of this week, we'll kind of make some adjustments for next week. The next thing I want to point out is there are a bunch of due dates, and I had put them all in Canvas, but I'm not sure that we're checking that, so I just want to make sure that we're aware of all the deadlines that are here. And also frame this, if you don't complete an assignment by the due date, I'm assuming that you're choosing not to complete that assignment, which again is fine by me if you don't want to complete an assignment, but it will go in as a 0. I use that to keep track of who's done what. Okay, so I'm not going to wait until the end to figure out who's done what. I will not chase you down if you have missing assignments. If it's not in, you get the 0. So a few things. Classwork number 9 is due by midnight tonight. Exam number 3 is due by 9:35 on Wednesday morning. Classwork number 10 is due by midnight on July 9th. And the chapter 7 homework is due on Wednesday as well. So it's a pretty heavy week in terms of assignments. Quiz number 6, which is on your My Math Lab, is due by midnight on Sunday, July 12th. Okay, so classwork is on Canvas, your homework and your quizzes are on My Math Lab, and the exam will also be on Canvas. And last but not least, everyone should have their exam 2 graded. If you have any questions or concerns, feel free to schedule a meeting with me. I know it's always weird to kind of talk about grades via email or even in chat. It sometimes feels like it's not, I don't know, it's just not as easy to do. So schedule a time to chat with me. I'm happy to go over that exam and see what kind of questions you have. Your current grade on Canvas should be updated to include all of the assignments that were due up until now. Many of you are doing a super, super great job of keeping up with the work, and I know it's a lot, so thank you for that. But some of you are regularly skipping assignments, which I only assume means you don't want to do them out of choice. So just know that at some point in the semester, it's going to be too late to earn back all those points. And also, I'm not grading a bunch of stuff like the night before grades are due. So you guys need to figure out how to get all these, start working on any assignments that you're missing if you are. And if you do complete late assignments, it's on you to email me and let me know that you completed them. Otherwise, I'm not going back to check who's done what, okay? We only have 4 weeks left, so if you're in it to win it, then now is the time to make sure you're doing what you need to do. And for some of us, we may be too far behind point-wise at this point to make it up. So I would encourage you to look at that withdraw deadline if that is a situation that applies to you, okay? I saw there were a couple questions in the chat, so I just want to go through that. Today is the 6th. Yes, did I type a date wrong? Today is the 6th. Monday, July 6th, yes, sorry. Right, I will correct that later, sorry.
So the homework is due on Thursday instead of Wednesday because the 9th is on Thursday.
Yes, the 9th is on Thursday.
And the exam is still tomorrow, but it's due the 8th?
Yes.
Okay.
Yeah. Okay. If you have specific questions about your own grades, I do not want to take class time to deal with that. So again, please schedule a meeting with me or send me an email with what you have questions on, okay? If you have questions on content, again, you can reach out to me via email, but I want to make sure that we have enough time to get through today's last lecture, okay? I will update the deadlines later today after we're done with class, so thank you for pointing that out. I will update that so that the dates are correct.
I just have one question. Sorry, I'm a little bit slow, and I probably just couldn't find it. Maybe I wasn't opening my eyes. Your email, I didn't see it anywhere in the modules. I could have just not been looking, but I didn't notice it.
Notice what?
Where your email is, like what your actual email is.
Oh, what my email is?
Yes, yes, yes.
I think your professor had sent that out, but you can also message me through Canvas.
Okay, sweet,
okay?
Thank you.
Yeah. All right, so folks, again, if you have individual questions, email me or message me through Canvas. I'm happy to address that. But for right now, I would like to move on with the lesson just because we have quite a bit of stuff to cover today, okay? So I'm gonna stop the share right here. And I'm gonna go ahead and share my note screen so we can finish up the lesson from Thursday of last week. All right, so last week we started 7.4 on Thursday. We did not get a chance to finish, and so that's what I want to finish up in this first half of class. And we were practicing using inverse trig functions to help us find trig values. And so we talked about a case where we needed to be really careful about whether we needed to rename our angle or not. Okay, so that's something to definitely keep an eye on. And also making sure that it was on the right side of the unit circle, the correct side of the unit circle. So for arcsine and arctangent, we needed to pick from the right-hand side, but for arccosine, we needed to pick from the top half of the unit circle, okay? So really, as you're studying, think about how to make those decisions about what to have and what you might need to name your angle. And that was the only example we had a chance to work through. And so let's pick up here with example 2, where we're going to be finding the exact value of these trig functions that they're giving us, okay? So what we need to do, just like we did for the previous one, is we're going to work from the inside out, okay? So here's what I mean by this. I think question A looks a little intimidating, but what I like to do is take it one piece at a time. And so we're going to go ahead and address this inside piece first, okay? So using your unit circle, what is sine of 2 pi over 3?
Like the angle?
No, what is sine of 2 pi over 3?
Root 3 over 2.
Root 3 over 2.
Yep, root 3 over 2, right? So we're going to the angle and we're finding the y value that is there, okay? So when you're working these problems, start with the inside piece, figure out what that is, and then what you'll end up with is a simpler case of what we had before. And so now we're trying to find the inverse sine of root 3 over 2. And as soon as I see this inverse sine, I know that my answer should be an angle. And so what I'm trying to find is an angle that has a y value of root 3 over 2, okay? And when I look at my unit circle, I see a few options. I see that it could be 2 pi over 3, but it could also be pi over 3, okay? Which one of those is the correct answers and why?
Pi over 3.
Pi over 3 is the correct answer. Good. Now tell me why.
Because of the range of sign, which is only goes from pi over 2 to negative pi over 2.
Yeah, our answer for theta needs to be between negative pi over 2 and pi over 2. Okay, so that's why we can say pi over 3 is an answer, but 2 pi over 3 is not our answer. All right, let's try question B. I have arc cosine of 4 pi over 3. And same thing, I'm going to go ahead and find the inside piece first. All right, so using your unit circle, can someone tell me what cosine of 4 pi over 3 is?
Negative 1/2.
It is negative 1/2. Okay. And so all I've done is that turn that cosine 4 pi over 3 into its equivalent, which is negative 1/2. And now I need to find angles that have an x value of negative 1/2. So that could be 4 pi over 3. What else could it be?
2 pi over 3.
2 pi over 3. Okay, so anything on that left half of the unit circle. And of these two, which one is correct and why?
Two pi over 3.
Tell us why.
Because range goes to 0 to.
Good. We want to choose from the top half of that unit circle, okay? And so this one is not our correct answer, but it is the 2 pi over 3. All right, one last question. The arctan of the tangent of 7 pi over 6. And so we're going to approach this the same way. We're going to find tangent of 7 pi over 6. And then we're going to go ahead and replace that in our expression. So if I go to 7 pi over 6, what is the y value there?
1/2.
The y value at 7 pi over 6 is not 1/2.
Negative 1/2.
It is negative 1/2, yeah. And the x value there?
Negative root 3 over 2.
Negative root 3 over 2, good. Now, I'm not going to simplify right here because I'm going to turn around and find the angle that has these x and y values. okay? So I want to find an angle that has a y value of -1/2 and an x value of √3/2. And so when I look at the unit circle, I see a 7π/6 that fulfills that. But I also see, do I see anything else that fulfills that?
No.
No, but what happens to these signs though? Negative divided by negative
Becomes a positive.
turns into a positive, which means I could actually use the positive versions of those because it would simplify to the same thing. Okay, so the place where the sine is 1/2 and the cosine is √3/2 is π/6. And so of these two, π/6 is the correct answer because, like sine, we need to choose from the right half of the unit circle, and 7π/6 is on the left side of the unit circle.
Teacher, I have a question. Isn't the π/2 and -π/2 is not included in the range since there are parentheses?
Oh yes, for arctan that is correct. Yeah, because it's undefined there. Thank you.
Thank you.
Okay. All right, so we've got example 2 where we have the arcsine and the sine, or arc cosine and cosine, or arctan and tan. And now we're going to take a look at what happens if we sort of mix and match, okay? So like we're not necessarily pairing arcsine with sine or arc cosine with cosine, but we're going to mix and match the different trig functions. Okay. So in these cases, I find that drawing triangles definitely helps to figure out what the answer is. Okay. So like the last question, for part A, we have cotangent of arcsine of 2/3. I'm going to find out what this is, except I'm going to find that using a diagram. Okay. And so here's what I mean by that. I see arcsine is positive. So I know that that angle is in the first quadrant. And sine gives me opposite over adjacent on a triangle. So 2 is the opposite and 3 is the hypotenuse. Okay, so opposite and hypotenuse mean on my triangle, I can label the opposite side as 2 and the hypotenuse as 3. How do I find the missing side?
A squared plus B squared equals 3 squared.
Good, yeah. So we can use our Pythagorean identity. And so that'll give me a squared, whoops. A squared equals, let's see, 9 minus 4 is 5. So A equals the square root of 5. Or this adjacent side is equal to the square root of 5. Okay. Now with this, now that I've found my triangle, let's go back to the definition of cotangent. Cotangent of any angle is the ratio of what side over what side?
Adjacent over opposite.
Sorry. Cotangent of theta equals hypotenuse. Nope, sorry, not hypotenuse. It should be adjacent over opposite. Okay. So from my triangle, the adjacent side is √5. So I put that up on the top. And my opposite side is 2, so I put that on the bottom. And that's my answer. Okay. So we really want to go back to the definition of all these different trig functions. So knowing SOHCAHTOA and like what the different ratios are is definitely very helpful. All right. Let's try part B. Now looking at that arctan, I notice that it's negative. That means that my triangle or my angle is in quadrant 2. Okay? So here's my theta. The opposite is the top number and the hypotenuse is the bottom number. So my opposite side here is going to be 3. Oh, sorry, adjacent. And my adjacent side is going to be -5. And so I can use this Pythagorean theorem to find that missing side again. So I'm going to get 3 squared plus -5 squared equals c squared. And I get 9 plus 25 equals c squared, or that hypotenuse is the square root of 34. Now secant theta is the ratio of what two sides on my triangle?
Hypotenuse over adjacent.
Very good, because it's the reciprocal of cosine. Good. So I'm going to take my hypotenuse, put that in the numerator, and I'm going to take my adjacent and put that in the denominator. And that's my answer.
Does it matter which side goes negative when you have a fraction like that?
It does, because if I put the negative with the 3, first of all, that doesn't make sense with my diagram. And second of all, that's going to get me the wrong sign for my answer.
Okay.
Okay.
Well, why did you put it in quadrant 2 instead of quadrant 4?
You could put it in quadrant 4 as well, and I think we would end up with whatever your diagram is. I want your diagram to match your answer. Does that make sense?
Okay, thank you.
I have a question. How do you know that the 5 is negative and not the 3?
Well, because here's my origin. So 5 is in the negative direction, so it has to be the negative.
Okay.
Okay. So that vertex is always at the origin. Like where your angle is, that's the origin.
Okay.
Okay. All right, so last one here. Like the previous ones, we're going to figure out that inside piece, but we're going to figure it out using a triangle. So I know my cosine is -1/4. So again, that's my Q that is going to be in quadrant 2. So adjacent over hypotenuse. And I can use my Pythagorean theorem to find the angle of the missing side, or the missing side length. So I get -1 squared plus b squared equals 4 squared, or 1 plus b squared equals 16, or b squared equals 15. And that means my opposite side is the square root of 15. And when I think about cosecant, I know that is the reciprocal of sine. So it is the hypotenuse over the opposite. And so our answer is 4 over root 15. If you want to rationalize this, you're more than welcome to, but it's also fine to leave it like this. All right, any questions on number 3? Okay. All right. So I want to do a couple examples where we don't necessarily have numbers, but we're still going to be able to write an expression at the end, and it's going to have x's in our answer. Okay, so it's okay that we don't get to a statement that is fully with numbers. It's gonna maintain whatever we have inside there, okay? So the first question is sine of inverse tan of x. And like before, we're gonna figure out that inside piece first. And we're gonna figure that out using a triangle. So we draw our right triangle, we label our theta, and I know that tangent is opposite over adjacent, so I can say that the opposite is x, but what's the adjacent side here?
1.
It is 1, very good. So I've got a 1 here, and guess what I can do? I can solve for the hypotenuse the same way I did before using the Pythagorean theorem. It'll just have an x because I'm having an expression for that side, not an actual number. So I know that x squared plus 1 squared equals c squared. That means that the hypotenuse is the square root of x squared plus 1. Okay. Now, when I go back, I know that sine is opposite over hypotenuse, so I'm going to put in opposite, which is x, over the hypotenuse, which is the square root of x squared plus 1, and that is my answer. Okay? Now, when you get to Calc 2, there's going to be a lot of questions where you're going to be doing some fancier math stuff, but at the end, this step right here is going to be crucial in getting you back to your actual answer, okay? All right. So for part B, I have the tangent of the arc cosine of x. And arc cosine is just another way of writing cosine with the -1. I just wanted us to see it written that way so that we could remember that both ways are okay. And so same thing, I know that I'm going to start with the inside first. I know even that my answer is going to be a fraction. And to get there, I'm going to draw a triangle, find out all the sides so that I can plug those sides into my ratio. So cosine is adjacent over hypotenuse. So adjacent over hypotenuse. So I've got x for the adjacent and a hypotenuse of 1. What does that make the opposite side?
Just like a variable, so it would be 1 minus x, 1 squared minus x squared equals something squared.
You've got some parts of it in there, but it's not coming out quite right. Anybody want to jump in? What is the length of that opposite side?
The square root of 1 minus x squared.
Yeah, I just plug that into the Pythagorean theorem, and I have my hypotenuse minus the adjacent squared. Okay. So now that I've got all 3 sides, I can plug them in to put the ratio for tangent, which is opposite over adjacent. And that's it. Okay. Any questions on example 3 or 4? All right. All right. So we're actually going to skip this last part here because our whole 12.5, or sorry, not 12.5, our whole last section is about solving trig equations in 7.5. Okay, so we're going to skip this one because we're going to get a lot more extra practice in the next section, and I want to make sure we have a chance to go through all of those examples. Okay, so I'm going to stop my screen share. I'm going to stop the recording.